Hey guys, Dr. Brown here with Kubo Math, and tonight this is Calculus 2. We're continuing the integration of inverse trig functions, or that general topic, I guess I should say. Now I saw this chart, black pen, red pen. I would encourage you to look at his site. The guy's phenomenal. But he put this chart up and it really helped me. And so I wanted to pass it along to you guys. When you look at a problem, now you'll notice in this integral we're looking at here is the integral of the square root of a squared minus x squared. Now if you look at this chart, if you see this, one of these in your problem, and of course in our case we have this one, but let me talk about these others first. If you just see x squared plus a squared, if you were to let x equal a tangent theta. So just imagine you're putting in a tangent theta for x and then squaring that parentheses. You end up with a squared tangent squared plus a squared, all under the radical. Okay, well if you factor out a squared, you end up with this right here, tangent squared plus 1 inside the parentheses with a squared on the outside of the parentheses. So the square root of a squared is a, that can go outside the radical, and the square root of, or this equals secant squared. Now the square root of secant squared is secant. Okay, now there is sort of derivatives here you have to be able to deal with. So in this case you probably need to be able to integrate secant cubed. So you'll have to work with that one. Same concept here. You can just look at that and say, wow, that's sort of like secant squared minus 1, or that form. So again, let x equal a secant theta, put it in here, square it, and you go through the same concept then of factoring out the a squared, and you end up with secant squared minus 1 inside the parentheses under the radical, and that's tangent squared, square root of that's tangent. Now in our case, we have the integral of a squared minus x squared under the radical, so we see this. And now we're going to let x equal a sine theta. We'll square that, and the same concept. Then we'll factor out the a squared. We'll end up with 1 minus sine squared under the radical. Well, that's cosine squared. Take the square root of cosine squared. It gives me cosine. Now again, once I put this in, I still have a dx I have to deal with. We'll show you how this works. Okay, so what do we see? We see this. So let's let x equal a sine theta. So I have the integral of the square root of a squared minus a sine theta. Well, I should put that here. X equals a sine theta. Dx equals a is a constant. Derivative of sine is cosine, so cosine theta d theta. So dx, I need to replace it with a cosine theta d theta. Okay, so I have all of this here that I'm dealing with. Oh, and that's squared. All right, so that's x squared. So what does that give me? I'm going to bring this a to the front. Okay, put it over here. So I have the square root of a squared minus, we're squaring what's inside the parentheses. That's a squared sine squared theta times, I brought the a over here, cosine theta d theta. Okay, let me factor, that's a bad looking a. All right, so I have a times the integral of the square root. I'm going to factor a squared out. A squared times 1 minus sine squared. Oh, you can see how it's shaping up. Cosine theta d theta. Okay, 1 minus sine squared is cosine squared. Also, I can factor or take the square root of this. You know, if I have square root of a times b, that's square root of a times square root of b. So in this case, I'm going to take the square root of that, pull it out. It's a. So it ends up going right there. So that a, square root of a squared is a times a is a squared. But I still have 1 minus sine squared, which is cosine squared theta, times cosine theta d theta. Square root of cosine squared is cosine. So that cosine times this cosine gives me cosine squared. So I still have the integral of cosine squared theta d theta. Okay? All right, we got that far. Let's see what we can do here. Now, all right, so what we did first was a trig sub. Okay? Next, we're going to do a power reduction. So I'm going to try to get rid of the cosine square and bring that down to a simple term. So in this case, I have cosine squared theta, and that equals 1 plus cosine 2 theta all over 2. So I can substitute that for cosine square. So let me do that. So I have the integral of, I'm going to bring that 1/2 out. 1/2 actually d theta plus 1/2 times cosine 2 theta d theta. Well, let me do a short u sub just so I don't mess up in my mind. If I let u equal 2 theta, du equals 2 d theta. So du over 2 equals d theta. All right. I'm going to keep this one in the theta world. Actually, I'm just going to go ahead and integrate it. So integration of 1/2. If I pull that 1/2 to the outside, so the integral of d theta is just theta. So I have 1/2. Oh, my a squared. I almost forgot that guy, right? A squared. And we'll put him, I guess, right here. So I have a squared times 1/2 theta plus the integral, I'll move that a squared over 2 outside, cosine, I'm going to substitute cosine u and du over 2, but I'm going to move that 1/2 over here, which will make 1/2 times 1/2 will make that a 1/4. So I have a squared over 4 times the integral of cosine u du. Well, the derivative of cosines minus sine, the integral is positive sine. So all of this ends up being a squared 1/2 theta plus a squared over 4 times sine u, but u is 2 theta. I'll go ahead and go back to the theta world here. Okay, now we've got to get rid of theta and get back to the x world. So sine theta was x. X equals a sine theta. X equals a sine theta. So x over a equals sine theta. Okay, if I draw this triangle, and I said, well, theta is x over a, opposite over hypotenuse. That means theta equals sine inverse x over a. And then okay, so let's leave it at that. Well, let's go ahead and just, while we're here, this side would be a squared minus x squared. So the hypotenuse squared minus this other side squared gives me this side. Whew, okay. All right. Well, we've got another challenge here. What are we going to do with that? Sine of twice an angle. I know. Sine of 2 theta equals 2 sine theta cosine theta. Understanding trig is critical, okay? So what does that mean? So here we are. We've got, we'll scoot over just a little bit here. A squared times 1/2 theta. Theta was sine inverse x over a. Okay. Plus a squared over 4. And this was sine 2 theta, but now we're saying that's 2 sine theta cosine theta. Well, 2 over 4 gives me a 1/2. So I've got a squared, times 1/2 sine inverse x over a plus a squared. I know I could factor that out. I understand. 2 over 4 gives me a 2 here, so I have another 1/2. Sine theta. Sine is x over a. And then cosine is the square root of a squared minus x squared over a. So it's adjacent over hypotenuse. Well, now I've got a times a is a squared. That will cancel that one. So those cancel. So now let me take this still. I'm going to pull the 1/2 out now. So now I have, bring the 1/2 to the front. I've got a squared times sine inverse x over a plus 1/2's out here. A squared just canceled. X times the square root of a squared minus x squared. And that, my friend, is that integral. Now this is a common one to see. So if you can remember, commit this to memory, or at least know where to get it, it becomes handy for you. But this general concept, if you see these, let x equal one of those, whichever thing you've seen, and then you'll ultimately use that. So this little matrix, I would encourage you to take a snapshot of that, stick it in your phone or in your notebook somewhere, wherever your reference material is kept, because it's really handy. So, okay, that's where that comes from, that useful formulation from that integral. All right, guys, why are we doing this? We're trying to build a better tomorrow and do that through math. Okay, study, study, study. Keep working problems. Find things like this and just try to noodle around on it and see where it came from, okay? And I have a little saying at the bottom. Today is the day you make a difference. Seize the day. Do that every day. Okay, that's enough for now, and we'll talk to you next time. Thanks.